Right, this is a little project I've been wanting to do for a little while. This is to do with overhauling my bench lighting setup. You would have seen some mailbags recently. I've received this power supply, this little converter here, which is 12 volt to, well, actually I think it's up to 40 volts it can do. Just 5 volt converter, right? And I've got other bits and pieces here as well. Now, the project here is to put this power supply into this box, which is going to be a 12 volt supply, which I'm going to wind down to probably 11 volts, possibly 10 volts, depending on what the adjustment can go down to. I haven't actually tried that yet. I'm going to build it into this box, drop it down as low as I can, between 9 and 12 volts, and use that to run my bench lighting. So the idea is that I put these banana sockets on the back there as binding posts, and run some wires off to wherever I need to power. So this unit here will be on a in a separate box, which I have ordered. One box I've got a little bit too big, so I've ordered some smaller boxes, so they're not here yet, so I can't do this part of the project yet. But so like 12 volts coming out of this box here, so I'll just put this to one side, and that can run to my 12 volt lighting, and it will also run to that module there into its own box, which I can then use to power the 5 volt lighting I've got here, which is this light just there, which I've also done in a recent review and mailbag thing, and because that's USB powered, and that USB socket also then power my LCD microscope, which you would have seen in my review video and mailbag too, and anything else I may need to power from USB. So I've always wanted to have a little USB bench supply here. What I've actually got is a power supply plugged into the wall underneath my desk, well, underneath one of my shelves here. Not so convenient, so I want to put this unit here into a little box directly beneath the shelf, so it's like right at the front and you can just get to it really easily, you know. That's the plan. So this is the first stage of the project, is to first sort out a 12 volt supply. Now this unit here, say rated at 10 amps apparently, 12 volt 10 amps, but if you look at the circuitry in here, there's a diode there, hope you can see it through the mesh. Alright, there's a single diode there, dual diode in a TRT20 package, and there's another device at the end there, just a single one. So I'm thinking 10 amps is probably a little bit optimistic. Now it's likely that it's been overrated, so I don't think I'm actually going to get 10 amps out of this unit. But that doesn't matter, because I'm not actually trying to run a big supply off it, I'm just trying to run some lights. So 5 amps for me is probably going to be enough to run the lighting and all the USB connections and options I need to use. So even if it is actually a 5 amp, maybe it doubled it. Yeah, we'll see how we go, but I'm suspicious that this isn't a 10 amp unit. It may be fine, it may actually be correct, but I'm just suspicious. It looks a bit simple for a 10 amp. Anyway, so I'll see. One of the things I've got to watch out for is how much noise this thing produces. Now, as I do a lot of RF work, having any spurious noise and common mode noise coming through from anything, such as power supplies, can be problematic, especially if you're trying to do very small RF readings. Any kind of radiated noise can be a real problem. Now I've actually got a little bench power supply which I could have used instead of this, right? But I know that is noisy. It's just a little cheapy switch mode unit, which I've actually quietened down by putting more filtering into it, but it's still a bit noisy. And so I'm hoping this will be quieter. I'm actually half tempted to put this into a metal box. I mean, this is obviously a plastic box. What I like about it is it's got these flanges on it, so I can mount it to a surface. So I'm actually going to mount this on the end of my desk, so I can put a switch on the front of it. So I'm just going to drop that unit in there like so, and actually rather conveniently has some holes which line up. So there's a hole just here which lines up, and at the other end there's also one on the opposite corner which lines up perfectly to a mounting post, so it can actually just screw straight in like that, which is perfect. So it's going to mount in there like so. I'm going to put binding posts. Now I'm probably going to put it on the back there, but if I have power coming in this side, then I'll put the switch on that side instead. So the switch is probably going to go that end, binding post this end, with cable entry this end as well. Right, now I've got a fuse holder here, and the plan there is to just go in between the output terminal and the binding post, so that there's at least some kind of output protection. There's input protection fuse in there. There's no output protection. Well, there's nothing I can see, so I want to put a fuse in there. This is the fuse I've already put in here is a 5 amp fuse. Now, like I said, I believe this is, I think 10 amps is probably pushing it for this unit. Now, 5 amp fuse will go up to 10 amps, but only for, I think it's about 2 seconds or something like that. It will run about 2 seconds. Depends on the fusing factor of the fuse and that sort of stuff. So, there's actually quite interesting about the whole way fuses are rated, and their fusing factors and things like that. So maybe I should do a little video on that sometime. My understanding is not brilliant on it, but I know enough to be able to understand how it works. Basically, a 5 amp rating means you can do 5 amps continuously, but once you go above that, depending on how high above that you go, you'll blow within a certain time. And if you look at data sheets of fuses, you can see there's actually a graph for how quickly it will blow versus the current going through the fuse, and that is determined as well by the fusing factor, like a slow blow versus a fast blow fuse. It's got a different fusing factor rating. You know, it might be 2.5 times or 5 times, or whatever, and that depends. That determines that curve of how quickly it will blow. Anyway, I'm digressing slightly. So the plan here is to put just a switch on the front, so that'll be the front there like that, and I'll put a switch on there just like that, and that'll be all on the front edge, right? And then on the back, so I'll put those binding posts on the back. So I've got the output, there's 12 volt output on the back, 3 binding posts, and then that can run off to whatever I need to go to. So this is a separate unit, and this can do multiple things. Obviously I can use it not necessarily for lighting, or maybe I use it, repurpose it one day for something else if I change what I'm doing or change how I set it up. Okay, so that's that. I'm going to go and mark this up and come back. Right, so one of the things I want to do is obviously make sure that the binding posts are set at a suitable distance apart, so it's like a standardised distance. So if you've got a 2-pronged connector, you can just plug it straight in, like channel multimeter or power supplies, because it's all standardised. Now, I don't actually know what the distance is offhand. I'm sure it's documented somewhere, so I'm going to measure it instead. So let's just bring this camera around and I'll just show you what I mean. Okay, so I've put a line here roughly at the height where I want the post to be, just gives it clearance on the terminals on the box and stuff on the supply, so it's above it, so there won't be any interference between the parts. Now I've set this at 19mm and locked it in place, so all I've really got to do is just scratch this to say there. Alright, so if I just do the scratch, that should give me the distance I need. If I get a scratch on both sides, it'll be good. Alright, there you go, so I've got 19mm there. If I unlock it and just measure it, it should be, just to verify, it should be okay, but yeah, 19. Alright, so all good. Doesn't have to be that precise anyway, but so yeah, that's that part done. Alright, so the binding posts, the holes I need for these, let's have a look, see what size I need. Now I could just do it straight on the shaft, but that's, you know, a little bit interesting. Now ideally it's got a flat on here, so I should probably try and get it to lock onto that flat. So really I should try and shape it for that, but I'm probably what I'm likely to end up doing is just drop it on there and gluing it so it can't turn. So if I go to that diameter there, that's 9mm. Let's check the other side. That's times it there again, 9mm. So yeah, that's fine. So I'll do a 9mm hole on each of those. I'll sort those ones out. Alright, so I've got a cable gland here which is probably just about the right size for this cable. It'll squash down pretty well. I think it's about the right size. So I've got to figure out how to dimension the hole for this gland. Now if I assume it goes all the way in, which is probably what's going to happen, in order to push the cable into the depression inside it, all I really need to do is make sure these are flush and measure that distance in that slot, and hope that it will actually get that low. Let's measure that. So that's 15mm pretty much, and that dimension is 13.5. So I have a elongated slot, or I could just drill a 15mm hole. I mean, it will go down to 13, but that's not the right size for that gland or that cable. If I make the hole bigger, the 15mm there, that's too big for the gland itself. So if I did, I'm going to have to do this by hand anyway, because I don't have any drill bits to go that big. I'm going to have to ream that out anyway, so it might end up being, I can probably elongate it with the reamer, it's not a problem. So that's what I'll watch out for anyway, so I can probably get it that wide. If I drill it to that size, 13mm or so, I think I've got a 30mm drill bit, and then I'll tune it from there. And the last tricky bit is the switch. Or being a rectangular switch, you know, it's not so easy. I looked through my various switches and bits of gear, and I've got toggle switches, but they're really marginal on the rating. I don't like to use a toggle switch with a metal body and a metal switch on a mains input, right? Because this is going to be mains input of switching, right? Whereas this is all insulated and it's rated. It says it's what's it say? 6 amp, 250 volt. Well, I'm not sure about 6 amps, but I'd halve it, say 3 amps. But it's still going to be ample. All right. So, and that's insulated. So that's what I like about this, is that you're not coming into contact with any bits of metal, which could potentially come live if the switch fails. So I prefer to use completely insulated switches on mains gear, even if it's supposed to be rated for it. So I've got to also do the same thing with this and cut this out. Now I do have a nibbler tool, but this is too thick for the nibbler, so I'm going to have to cut that out, probably with a knife or a pair of cutters or something, and eke that out. You can use a soldering iron, but I highly recommend you don't, unless it's a soldering iron you don't intend to ever solder with ever again, because it tends to ruin the tips. So it's 14mm, well 13mm that way, and 9mm that way, so 9mm again. So if I use a 9mm bit and do probably two drill holes, separated apart by a little bit, that will get most of the way there. I'll just have to square it off with maybe even a file will do. I've probably got a small file and get in there. So that's the plan. Okay, so I'll just roughly mark this out. It's, you know, do a bit of spearing. I'll give it a clean afterwards. But those are the holes I've got to cut. So that's the cable entry, that's the binding post, and that's the switch on the front. Now I'm thinking maybe I should put an LED on the front to show it's on. 12 volt LED. Yeah, let's do that. I shall stick a LED right there too. Or not. Right, so I've got the all the holes done in it. Now I was actually considering ventilation, right? So I was thinking about putting some holes down this side and holes down this side. Thinking, well, it may or may not need it. I mean, I might just have to run it and see how it goes, see if it gets warm or not. If it gets a bit warm, then I'll probably put some ventilation holes in it, and it may even require a fan. Okay, so if it needs a fan, I'll probably have to do something, you know, externally mount one on the bottom or something, blowing through a bigger hole in the bottom, you know, with some holes in the top. I mean, that's certainly possible. There's not a room inside next to the actual unit to add a fan in once it's actually located, and that's where it sits like that. So there's not really a lot of room here for fan. If I wanted to put one inside, it wouldn't be very effective because it would be mostly blocked. I mean, it's possible, you know, a small little fan might fit in there, but it's too close to the heatsink really. So I'll see how it goes. I mean, if it gets warm, then I'll put some ventilation holes in, and if it still runs too hot, then I'll put a fan on there, probably on the bottom side there, so it sucks air in the bottom and blows it out the top. That bit of, you know, because that way helps the there's a name for it. There's an airflow name. To do with heat rising. I've forgotten. My mind's gone blank. Anyway, because naturally, if you have natural ventilation, the air comes in because the heat's rising and sucks air in the bottom. You know, so it's natural. Can't think of this gone. I'm sure it begins with a C. Anyway, right. So that's the plan. So I shall try it as it is for now to try and keep it sealed. You know, because I want to keep the dirt out of it and dust out of it and things like that. So if I can do it without having to have ventilation on the outside, then I'll do it. But it depends how hot this gets in use. What I'll probably do is poke a thermocouple in there, and we'll just monitor it and see how it goes. If it gets too warm in here, then say I'll add in ventilation. So Alright, now I just need to figure out which way I want to do this. I need to poke this LED through there, so I'll probably put the power supply module in afterwards. I should just be able to drop it in like that. Yeah, so I'll fit everything else on the outside first and I'll put the power supply bit in last, and we'll go from there. Alright, so now I'm going to start wiring this up. So this fuse holder here, I'm just going to strip this off, and I'm going to keep the wire intact at the same length, and just coil it up out of the way. I'm not going to keep it, not going to cut it down, because I may reuse that later on for something else if this ever fails. And I've got some black wire here. Now this is supposed to be about 7 amp rated, I think, but it's, yeah, we'll see. It's no worse than that one. It's only got to go a short distance, so I'm not too worried about it. But so I'll just cut this to length, and I've got some terminals here. This one's looking a bit tainted. I might have to get that bit of a clean up. And so I can mount all this together now, and so this one can probably just poke through. I'll be soldering onto this, so I'm going to poke this through now. Haven't tried this yet. Hopefully it will go through. There we go, it's in. Now it might push back out. It will, but because it's such thick plastic, it may not want to stay in place, even though it's got there. I've actually angled the side slightly to try and make it wedge a bit better on the actual mounts. I think it'll be alright. I might drop a bit of super glue on this on this just to hold it, just a little drip. Otherwise, we're right. Now this LED, it's a standard LED. This is going to be about 12 volt output, between 9 and 12 volts. So what I'll do is I'll put a series resistor on this, assuming 12 volts for maximum brightness. So if it's running less than that, it'll be alright. But it doesn't need to be super bright anyway, it needs to be visible that it's on. So I can do that in place as well. Again, I'll put a drip of super glue on that. I realise I haven't got any of the mounts left for the LEDs, those little 5mm mounts, which clip onto the LED. I've run out. When I realised, that's right, I forgot to order some more. So I've ordered some more now, but I'll be, a period of time sort of here. But I'll just, for now, this will be alright. This will be fine for this. And as far as these things go, I've just got to poke that through. I've already confirmed they sit nicely in the holes, so I've got to put that on, put the back on that, and then I shall use this once I've got the wire on it, and just tighten it up like so. Like that, okay. I'll just do that for both of them, thereabouts like that, and that should be fine. Now, what I'm probably going to do as well is put a bit of super glue on these mounts just to lock them in place, because the holes aren't keyed. And it needs that little bit extra just to help hold them straight so they don't turn if you're trying to use the screw terminals. So well, at least that's the plan. Alright, so that's all pretty straightforward really. A bit of finer soldering iron up. If I can reach it, I've got my stuff piled in the way. And so yeah, it should be pretty easy. Now I need to go and I'll just go away now and calculate the resistor value for the voltage drop. I'm going to run it, 2 volts. I'll assume 2 volts for that drop. Usually about 2.1. I could test it, but I can't bother. I'll just assume 2 volts, and I'll go away, calculate that, and then we'll go from there. Alright, so I've chosen a resistor for this. This is a 1/2 watt 750 ohm. Now, depending on the voltage input, the voltage supply for the LED between 9 and 12 volts, it's going to be between 11 and 15 milliamps to drive the LED. So, or thereabouts. So it's fine. I don't want to overdrive it. 20 milliamps isn't required. Doesn't mean it's super bright, but it does. This gives a bit more longevity and stuff like that as well. So run it slightly eased off. I always run things so they're not on the limit of their capability to help with longevity. So that's the resistor I'm going to use. So what I'm going to do is I'll touch it on the LED end and I'll run a wire around to the output. Now the power supply's got 2 sets of outputs, which is convenient. So I can use one set to go to the terminals and one set to go to the LED. So it's quite handy in that way. You keep them isolated. Right, so I've got a bit of wire here. It's just some really thin stuff. It doesn't matter because it's only for an LED. It's not like it's got to carry a lot of current. So I've already cut it to roughly the right length, and I'll do the other end to length when I get it right. Now I'm probably going to run underneath the unit, so rather than going around the top or around the edge, I'm just going to lay it on the bottom, and so it will run underneath there like so. Hopefully this doesn't get too hot. If it does, then it might be an issue. You might have to put something between them. Don't want to melt the wires. So I've cut this LED legs down to length. I've left the positive longer. So the anode side, if you want to call it, and I'm going to attach the LED to there. I'll just run it. I'll probably bend the leads around slightly actually, and just run it down like that, and run the wire there so it leads it round the right way. So it's all pretty simple. So let's strip some of this off and start getting ready for it. Both the wires in there. Just doing both at once is a bit of a cheat, but it's fine. Fortunately summer's here and it's getting a bit hot now. I'd love to have the air conditioning on, but it's a bit noisy. That's all ready to go. Now I'll do the LED ones as well, and I'll bend those around very slightly just to get it started in the right direction I suppose. Actually I'll do that after I've got the wires on there, because I want to heat shrink them. It's be easier to do once it's when it's still straight. So let's just cut this down. Doesn't need to be very long. Hopefully the camera can see this okay when I'm working on it without my hands being in the way. Make a bit of a mess of that. There we go. That's one. Always put the resistor on the positive side, or the anode side of LEDs. I just always do. Now I'm going to make the black one negative, green positive. Just the way my head works. Slip a bit more of that off. That's way too long, but that's fine. I should slip over, I should make sure. Yep. I'll probably shorten that wire very slightly actually to make it a bit easier. Same on that. Solder this in. Backwards, just turn around the other way, it'd be a bit easier. Right. Okay, now what I should have thought about is wire lengths. You can see now that one is not reaching. Right, I should have thought about that before, so let's just redo that one. Not a big deal, just a slight adjustment. So I need that to be about there. Okay, do this again. Too much solder on there really. I should now reach a bit better. Guess I've got it wrong again. It's still a bit short actually. Still a bit short, but I need to bit more generous with this. Maybe this time. Do you think my iron might be a bit hot? Yeah, it is. I had it turned up from before. So down a bit. Good enough. I'm not going to worry about insulating the other side. That'll be fine, I don't think. Or was I going to? Yes, I was going to, wasn't I? I've already cut a piece off of that. Let's get the blower going. It's the convenience having a hot air workstation is that you can use it for doing heat shrink. Once that's all fine, now what I'm going to do is bend that round. Like so. I'll go around here just fine. I'll tidy the other end up when I get there. So the switch I'm going to do last, because I've got to get the power supply in there, get the cable in, and then I'll run the cable. I'll adjust the length. I'll probably strip it back and use the same wire, go to there, and then just run another wire back. So it's I'll see how exactly I'll do that. I either run two wires and join it, or just run a single without a join. Running a single without a join is probably best, but the power wire is already quite short. It's only about probably 80 centimeters long, so I don't really want to waste all that distance there running over to there. I actually want to run across the top of the board like that, so it means my cable's like that long. It's not very long at all. It doesn't have to go very far though, but I'd rather keep it longer, so we shall see. Because of the cable length, I'm actually like to join it instead, actually, just to give more cable. I could get a spare IEC type, plug cable and cut the plug off that and just run it in, because I've got loads of those, I think, actually. But that one's already sitting there unused, so I might as well use that. Okay, so the next stage. Just gathering my thoughts here. So I want to get a piece of this wire here, strip that off, crimp it onto one of these, and start mounting these up. And the same for the one with the fuse too. So let's do that. Not sure how long this needs to be yet. This terminal's actually a bit big, but I've got this size because of the hole in the for the mounting post. Now I'm actually wondering if I should go down to a different size terminal. Actually, this is very loose in there. Let me go and have a look and see if I've got one which will work. Alright, so I do have one of these red ones which is a better fit for the wire, but these are some cheap Chinese ones. Are very thin metal. I'm not sure how good it's going to be. These ones are actually quite good quality ones, whereas these are not. Let's just crimp it and see how it happens, eh? I've got this crimp here which I tend to use. It's not necessarily the right one for the job, but it works quite well. Let's see if this will do it. It seems to be holding okay, so I might just leave it on that. I might just use that one. Okay, I'll do the same for the positive one then. Let's get another one. And I think I shall do this end of the wire. Okay. I actually prefer this crimper to the other one I've got. It works pretty well. I think I can do a double crimp on this one. Actually, yes, what I thought. Right, I can do double crimps on these. Oh no, I've pretty much got that one. Okay, alright. Not the best, but I'm not good at crimping terminals, I have to say. It's not something I'm good at. Alright. Let's mount this now. Which one am I going to do? Positive at the bottom. Positive at the top. So negative at the bottom. And on the negative wire here. Go that way. Got that. Need this one here. Right. Is that in place? There it is. Right. Okay. I won't tighten anything up yet, so I might need to adjust these or turn around a bit or something like that. I don't know yet. So I'll tighten them up after. And red one. Now these rely entirely on the nut conducting, just the way these are set up. Really, there should be a nut on the top side as well between the terminal and the nut. But, should be a washer, sorry. And yeah, we'll see. Right, so I shall put those on afterwards and adjust those. Get that out of the way for the time being. This is probably going to have to sit in there somehow. We might have to lay across there or something like that to get it tucked out the way. I'll figure that out after. I'll put these away. Now, I don't think I've got any bootlaces actually for doing these. I have to have a look. I actually think I'm at the point now where I should be putting it in anyway. I think I should be putting that in anyway. Right, I shall just get all this positioned up. Alright, so I've just got it just dropped in there for now. I've cut this wire here to length. I always allow plenty of room. I mean, for tidiness you would cut it exactly length and put it exactly where you want it. And I have done that for various things in the past, but I also like to keep some flexibility in the wires if you need to take this out and look at something. Sometimes having a little bit of extra wire on there is very, very helpful. So the fuse holder will stand quite nicely in that corner. That's actually low enough to sit in there just like that. It's quite nice. So that's what I'm going to do. I'm going to stand it up like that in that corner, tucked out the way. And the heatsink will actually just touch against it and help hold it in place. Actually, it's quite good. And I'll run that wire around and hook that in. I think I will cut this shorter actually. So it doesn't need to be that long. So I shall say that much there. That'll be enough. A little bit less mess in there, and so I don't think I've got any bootlaces for these. Let's see how we go. I'll go and have a look. No, I've got any bootlaces, so I have to make do. Not ideal, but it's okay. Alright, so that this little hinge hinges it up. I was expecting to unclip completely, but it just hinges up. So just enough length on that one. And on that one, that's fine. They go right in here. I mean, bootlace is the best because it helps protect the wire, but yeah, it's okay. It's not like it's an industrial environment with lots of vibration or anything. Okay, so I need to look at these wires here as well. So what I'll probably do is attach all these, and then drop it in, and then I'll do the AC versions in place. These I'm just going to trim these down, just tidy those up. Really should buy some bootlaces actually. I thought I had some, I must have used them all. This isn't the sort of thing I do very often, so it's at least not at home. Right, I think I'm ready to drop that in. So let's get a screwdriver. Right, I'm not sure if I can unscrew these actually, so I'll find out. Oh, pretty much there. So I should put these ones in first because they're the easy ones. We get the right polarity. Put those two in there. That's why I also like to leave the wires long, because it makes it a bit easier sometimes. Those ones there. Right, what I need to do now is get some screws that will fit inside these posts inside here to secure the module inside. Then I can do the next stages. I should be able to get onto there easy enough with my soldering iron. Shouldn't be a problem. Go find some screws. Right, I've got my drawer screws out here, and I found these two, which are thread cutting. They've got their own things, they need to cut threads, and they're about the right size for the posts, so they should do the job with a bit of luck. As long as the holes are deep enough. I may have to put some washers on them just to help them a little bit. We'll see how we go. So let's try fitting these in. See if it'll tighten. Yeah, that'll tighten down just does it. So that's okay. Let's get the other end in. Just makes it. Okay, that's right. And it's in there. So, the next thing I need to look at is now I can actually tighten these other terminals up and get these wires tucked out of the way. Try and tie these up a bit. Just need to adjust that around there. Get it to the back of the board. I just need to loosen it out a little bit. To route that wire properly. I want to keep it away from the 240 volt stuff. Like so. Need to keep good isolation in case something goes wrong. Okay, let's get out of the way now. Yeah, that's right. Just got to tighten those up. Let's make them spanners. Right, it's an 8mm spanner, so it fits these nuts. Should be tight enough, I'd imagine. Let's just loosen these heads off actually. They can grab and stop it from working. I think I might have done it already actually. Right. Now, does the orientation of the posts matter? Probably not. They're both in the same place, so that's right. Both going sideways. So that's fine. They'll be tight enough, they'll be right. And that should sit on there. Okay, so just have a look. Yep, that's definitely right. So next thing is the mains cable and how I'm going to manage that. Now, what I'll do is have those two going straight to the power supply. You always have to have a bit of slack in there though, so I'll probably strip some more of this back and then join this and run it over to there and run another wire back. That way I can keep as much flex as I can in place. Now, my favourite way of stripping back these things is to just snip along the actual insulation, and that way you avoid cutting into the inner insulation. It's just a bit safer. Right, I'll carry on with that for a little bit. Alright, so I've popped those two wires in there. Let's just tighten these up. Make sure the insulation's not underneath it. Right, I haven't put the gland on yet, but that's easy enough. So I'm going to try and route those so they sit. I should make them that way. So they sit this way out the way from the 12 volt stuff. Yeah, it's probably the best way. Now I need to extend this wire to that switch and back. Now I'm going to run it straight across the top of here. It shouldn't matter. Right, so I've got this brown wire here. It's a bit thinner than I'd like, but it should be adequate anyway. I mean, this is 10 amps at 12 volts. You know, what's that? Half an amp at mains voltage for 240 volt where I am. So half an amp. I'm not at full capacity. I'm not going to be using full capacity, so it's like quarter of an amp. It's fine. They'll be thick enough. So I'll be able to just join that there. I'll splice that and run it to there, and then run it back. I'm actually tempted to run around there, run around the outside, but that way I can lift this out. Actually, that might be a better idea. Make it slightly longer. So I'll join those first, and then go from there. Alright, so I've got a splicer on here. Let's just get the wire in. I'm using my favourite crimps. Yeah, that's fine. It's not going to pull off. So yeah, I will run it around the outside, I think. So that switch just to keep it under control, so I'll keep it like that. Then run it to there, like so. That way I can lift this out and work on it. Well, I could do the same I did the other side, right underneath. But, yeah, I'll just do it that way for now. Just do it like that. So get that off. A little bit of flux on there to make it a bit easier to solder. Yeah. So I always put the source voltage on the common, which is the center. This is a reason not to, so it's not forget the heat shrink. Okay, I should use a bit more flow on here, actually it's not very good. Better. Right. This iron's too hot. Still. Oh, wrong one. Right. Around there. I'll just pop this out. Hopefully. Put it like that. And back the other way. Solder my mat now. Do that. Need some flux. Come on. Here we go. And heat shrink. Okay. Okay, just cable ties together, tidy it up. Okay, so I'll just tuck that down the side. I'm going to shove that into that terminal and do it up. Give it a bit of a tug, make sure nothing's going to fall out. Fold down. It's all done. Now all I've got to do is put this in. Decide how much length I need sticking out to give it some flexibility. Probably not that much. So I've got to try and get the gland in. Here we go. It's in. So see, I've got to glue that, because it's not going to grab onto the plastic because it's too thick. In worst case, I'd change the gland to a different type, but this will have to do. I'll glue that in. Right, so that is actually ready for testing. It may work, it may go bang, we'll find out. Let's plug it in. Alright, moment of truth. Let's plug the pair in. No bang so far. I've got my meter here ready to go. Turn the power on. Well, the switch out once. Oh, LED is on. Just couldn't see it. Okay, that is working. So there is power there. Let's see what it's doing. $12 volts, bang on. Yes, okay. It said minus 12 volts, there you go. It said 12 volts that way around. Okay, so that's all good. That's not the right thing. Power it down again. So I should actually do some verification checks on a couple of things. Even though it's double insulated in this box, when I check to see if the shielding on the case is an earth connection. Right. Now, when you normally do this kind of thing, what you're supposed to do is have the earth wire as the longest wire, so that if it does get yanked out, it will pull the phase out and the neutral out before the earth. That's the theory, right? That's what's supposed to be done, but I haven't done it in this case because I've got a lot of wire and it's a lot of short, and this is going to be fixed in place anyway. It's going to be a fixed location. It's only going to be me that's using it, so it's going to be fine. So let's just do a continuity check for the 0 volts, or sorry, the earth connection. Let's do that. So stick on the earth and on the casing. Yep, that's fine. Let's measure the actual resistance. It's supposed to be less than 1 ohm. Yes, less than 1 ohm. It's about 0.2. I've got a connection on here. This actually needs cleaning up a little bit, it's a bit dirty. I'll do it on the probes. That's like 0.04 resistance there. So yeah, it's like it's about 0.15 ohms or something, which is certainly fine. Not like you're going to be touching that bit anyway. So yeah, it seems to be working. Now let's say it's putting out exactly 12 volts out. So I want to reduce that voltage. So it's just hook up to that. And I'll readjust my camera. Right, so I've got the probes hooked up. Let's turn the thing on. And plug it in, also helpful first. Plug it in first, then turn it on. Plug it in, then turn it on. Exactly 12 volts. So I want to drop that down a bit. I want it to be lower than that. Let's get a screwdriver. What can it go down to? That's the question. 11.5 is the lowest it can go. It feels like it's not a bad screwdriver for this actually. Let's find a better one. There we go. Right. So 11.1 is the lowest it will go, and it will go up to 12.7. So that's pretty well balanced actually. Right, but I want to run it at the low end. So that should be fine there. 11.1 volts. The reason I want to run it low is because it reduces the loading on the LED, which is right here. That's running at 9 volts right now. If I go to my power supply actually and increase that, that's 11 volts. Right, so that's 9, that's 11, so it's slightly brighter. It's 12 volt LED, and it's trying to keep the stress off the LED so it lasts longer. I've got two 10 watt LEDs in it, which is pulling out 0.6 of an amp at 9 volts. 0.6 at 11 volts, sorry, it's about 0.5 at 9 volts, so it's not a lot in it. 11 volts actually pretty much tops out the current. So 10 volts to 12 volts, the current doesn't change. So yeah, because the idea of this is it will free up my bench power supply. I won't have to worry about running the lights off the bench power supply anymore. Okay, so that's fine. I was just going to hook up the bring this round actually. As you can see, yep. Alright, these are the wires for my bench lighting for that one LED. I've got a few here, but that's just this one. So let's just get this in here. Oh, get it through the hole. Okay, turn it on. There we go. Bench lighting. So that started up okay. And it's probably one of the biggest currents it's going to be doing. And this is running pretty bright now, so that's 11 volts running on that. And we'll see how hot that gets as well. As well as this. We'll see how hot that gets too. Actually, that'd be running more than. What if I had my bench supply limited to 600 milliamps? I might have done actually. So this might be doing more current than that actually. This feels alright. Heatsink for the LEDs mounted on is getting a bit warmer. So yeah, it's a bit higher voltage than I wanted really, I think. Right, to give you some idea, this is the actual LED module I'm using. So I've just got two LEDs bolted onto a heatsink. Right, this is it. And I've got an 18 on here, 11 volt max. This is what I found from my experimentation about how it responds. And that's just for these currents. So 10.6 is for my 1.5 amp I believe. So it's running on the maximum of what I want on these. And this is getting quite hot. But since I'm running a high voltage, I probably don't need 2 now. I could probably drop it down to 1. And that'll reduce the heat being generated a little bit. But yeah, that's all simple enough, isn't it? So I just fed a little rubber strip into the lid of this box, and you notice there's a bit of a gap. So it's actually based on you having to stretch the rubber strip a little bit, which is not the best. But I'm not using this in a situation where it requires it anyway, so I'm not really worried about water tightness. But if you were worried about water tightness, you have to watch out for that kind of thing. So I'm going to put this lid on, and I've glued these bits in. I'll do that first, then I'll put the lid on.